So certain things have changed after Gidesh has left. Okay. So the things that have changed are that we have. I'm in another class.
Lady sleeping?
In the other class, we'll talk later. Okay. So sorry. So a couple of things that have changed. Gidesh is every class's video gets recorded, and you guys are supposed to watch the video and give comments there saying, okay, fine. Today in this class we learned this, and this is Gitesh, and in this class we have learned, let's say, geometric series or whatever we are learning. So that way it gives me an assurance that, okay, after the class you guys are revising things and making your own notes. Okay. If you don't do that, it's very easy to forget things. Okay. So that's the difference that I wanted you to be aware of. Now let's look at who all we have in the class, and I would request all the kids to keep their videos on, otherwise Ram, Ansika and Gitesh will be upset with me. They'll say, why only three of us? See, Devans is here as well. So we have Aryahi, Ananya, Ansika, Devans, Visali, Gitesh, Ram and Shikhar, and then we have Tanu and Vasundhara as well. So, if anybody is trying to recall, what did we do in the last class? Can somebody help me recall that? Gidesh would not know that, that's okay. Yes, Devans, go for it. That should be okay. I'm more concerned about about figuring out what did we do in the last class, so that we can continue from there. Ram, Thanu, Visali, anybody. You guys are supposed to have better memory than me. You guys are much younger than me. Somebody has to remind me what did we do in the last class. Yes, that is exactly what I was wanting to hear from you guys. So we talked about geometric series. We tried to understand what is geometric series, then what is geometric sequence, and then we tried deriving a formula for finding out the nth term of a geometric sequence, as well as how do we find out some of the finite terms of a geometric series. Okay. So that's what we did in the last class, and today's class we are going to literally go on a ride. We will apply those concepts for solving interesting word problems relating to geometric series. Is that okay? So for all of you, this is one of the reasons why I have been reminding you guys to watch the video of the class, because that will help you make sure that whatever we have done in the class, you guys are able to recollect that and apply it in the subsequent class, okay? Because these classes are interlinked, right? So just for today, I will just repeat what we learned in the last class. I am not going to prove the formula one more time, wasting everybody's precious time, but I will just help you guys recollect what we learned in the last class, and then we will get on to some interesting word problems relating to geometric series and sequence, okay? So we talked about geometric sequence, and that goes as, this is one of the examples, okay, where what we see is any two subsequent term, from this term to next term in the sequence, if I go, there is a common factor that gets applied. From 1 to 3, I have to multiply it by 3. From 3 to 9, we have to multiply by 3. From 9 to 27, it was a multiplication of 3 against 9. And this continues. So basically between any two subsequent terms, there is a common factor that you see. This is called common ratio, or R, denoted as R. Likewise, if you look at arithmetic series, then you have a common difference. Here you have a common ratio, meaning any new term is arrived at by multiplying the previous term by a certain number, which is the common ratio. Here in this case it was 3. If you look at 2, 4, 8, 8, 16, 32, here your common ratio is 2. And you will get all different flavors of it. Similarly, if you are looking at arithmetic series, you are looking at continued addition. So let's say 1, 3, 5, 7, 9. What you are seeing between two terms, there is a common difference. 1 to 3, there is a difference of 2. 3 to 5, there is a difference of 2. From 5 to 7, there is a difference of 2. So this is called common difference. Okay? So that is the basic premise of arithmetic and geometric series. So any arithmetic series, geometric series if you talk about, in more generalized form you can say this is A is the first term, then you have AR squared, AR cubed. This is how it keeps on increasing subsequently. So this is the first term, second term, third term, fourth term. Likewise, if you keep going, nth term will be AR to the power n minus 1. Because if you see here, first term has R to the power 0, second term has R to the power 1, third term has R to the power 2. So whichever term you are talking about, the power is 1 less than that. That's how it is the nth term. And we also found out how do you derive the sum of n terms of a geometric series, and that came out to be A into 1 minus R to the power n divided by 1 minus R. This is the formula that we derived. And how did we derive it? That is exactly what we did in the last class. So you guys can be relieved that you don't have to prove this formula. I proved this formula in the last class just to make sure that you guys are able to relate to the concept that we are using. So any formula that we talk about, I always tend to prove that for you guys so that you are very clear about how that formula came into existence. That was the only purpose. So you can either derive it by yourself or you can memorize the formula, totally up to you guys. But this is the formula that we derived in the last class. And here, sum of n terms of any geometric sequence. So there's a confusion between sequence and series, okay? People think that geometric sequence and geometric series both are the same thing. Actually not. Sequence is the pattern, like what you are seeing here. When you are adding certain terms of a sequence, this is given a name, geometric series. So in simple terms, sequence is just denoting the pattern, and series, when you see the word series next to the type of series we are dealing with, a sequence that we are dealing with, it's just denoting the sum of a finite number of terms. Okay? Is that okay? Gitesh, how difficult or easy it was to digest whatever I have said so far?
I learned this during the summer actually on my own in Khan Academy.
Okay, so you are familiar with what is geometric series and sequence, okay?
Yeah, I did geometry.
That's good. So now it's time for the ride. Meaning, I will read some questions and we will try solving it together one by one. Okay? So I have put those questions in the group also. Let's see how you guys are able to approach these problems. So everybody listen to the question carefully and then you will have your chance to break your head with that. So first question, a family trust starts with $5,000 in its first payout year. A family trust, I'm talking about the first question, okay? This says, a family trust starts with $5,000 in the first payout year. $5,000 in the first payout year, and each year the payout is 110% of the previous year's payout. So each year, this is the first year, it starts with this amount, and each year, okay, let me read the question. And each year the payout is 110% of the previous year's payout. payout is 110% of the previous year's payout. If the trust makes payout for 12 years, what is the total amount paid out? Let me read it one more time. A family trust starts with $5,000 in its first payout year. And each year the payout is 110% of the payout for the previous year. If the trust makes payouts for 12 years, what is the total amount paid out? Everybody heard the question? So there are only three numbers: $5,000, 110% payout, and 12 years. The question is, find out how much was the total amount paid out in 12 years basically. So let's see how you guys are calculating it and what is bothering you guys when you are solving it. Ram, Shikhar, Ansika, everybody got the question right? Tanu, Vasundhara, everybody? Gitesh, do you remember the question?
Yep.
Okay, have fun. Ananya, Disali, Devans, everybody, okay? I'm just calling out some names, that doesn't mean I'm just bothered about the names that are called out, okay? Okay, sure. So the question says, a family trust starts with $5,000 in the first payout year. $5,000 in the first payout year. And each year the payout is 110% of the previous year's payout. If the trust makes payouts for 12 years, what is the total amount paid out? Devans, does that clear your doubts with respect to what the question is? Okay, have fun then. Yes, Devans.
$15,692.
15,691.1. 92.1. Okay, okay. Shikhar. I'm sorry. Okay. You are still working on it, that means?
Yeah.
Okay.
Can you repeat the end of the question real quick?
Another question. Same
No,
one.
the end.
And part of it. Okay, okay. So, the
Like,
question.
where it says like the number of terms, yeah.
Okay. So I'll read from beginning, okay? So I don't know where.
Yeah.
A family trust starts with $5,000 in its first payout year, and each year the payout is 110% of the previous year's payout. If the trust makes payouts for 12 years, what is the total amount paid out?
Okay, so yeah, that's what I meant first. Right? I was just gonna clarify for that. I don't know. It's probably not right, but like I got 106921.
106921.
Yeah.
2.1, right? Okay. Yes, Devans. Yep. Okay. Okay.
Do you want the decimals too?
I mean, see, I am not really interested in going for exact value. I'm just trying to get a sense of how you guys are approaching the problem. Okay?
Yeah.
Ram, what's cooking up? What's there for dinner? Okay. Tanu, Vasundhara, what's there for dinner? That has become my favorite question now. Okay, I'll come back to Tanu and Vasundhara. Visali, tell me what did you get?
I got 2,692.1.
Okay. So, Ansika, I will not annoy you guys by asking what is there for dinner, but what is the answer you are getting? Still working on it? Yes, still working on it? Okay. Tanu and Vasundhara, Ram, Gitesh.
I'm still working on it.
Oh, okay. Yes, Gitesh, what did you get?
11,000.
11,000?
Yeah, exactly.
The exact 11,000?
Exactly 11,000.
Okay. We have a lot of diversity right now with the answers we have got. We'll see. Yes, Alsika. 15,600? 15,650, okay. So I'm using the first answer that Devans had given, which he corrected. So I'm using that slot for Ansika's answer. Okay. Yes, Vasundhara. Go ahead, brother.
I got 10,692.1.
Okay. So this one has more contenders. We'll see. Ansika and Vasundhara, you guys can put your hands down. I have noted down your answers. Let me see who is still working on it. So Ram, Tanu, and who else? Ananya. And Aryahi as well. So Ram, Tanu, Aryahi, and Nanya I'm waiting for. Otherwise, okay. So I'll give 30 more seconds, and then I'll get started. I'm sorry, brother? Okay, okay. That's okay. I mean, see, my whole idea is to get how you guys are approaching it. Okay, yes, Ansika.
I checked it and I got 10,600.
Okay, that's fine. So, Ansika is saying don't use this slot. Okay, we will see, whatever it is. Now, let me try solving it as a student. Let me not pretend to be a teacher here, okay? And then, we will see how is my brain processing this particular problem. So, for Gitesh, this screen is new, right? You have not seen this screen before. This is the change that has happened when you were not here. I was waiting for you to take a break so that I can see the screen. I'm just kidding. Okay, so here's the question. A family trust starts with $5,000 in its first payout year. So when I'm looking at the first year, there's a payout of $5,000. First year is $5,000. And each year the payout is 110% of the previous year's payout. So second year what is happening is, whatever is my payout previous year, this is 110% of that. Okay? So whatever is my payout for second year, when I go to third year, my payout is 5, this amount, whatever it is, 110% of that. So essentially what you are seeing is, it is getting multiplied by 110 by 100 every year. So this is a perfect example of a geometric sequence. This is my first year, next year is this, times this common ratio, the subsequent year is this, times common ratio square. Fourth year if I go, it will be 5000 into common ratio cube, and this is done for next 12 years. This is what it says. So 12th year we are talking about 5000 into 110 divided by 100 to the power 11. First year has no common ratio, second year has this number times the common ratio. So 12th year is this. And essentially we are trying to find out the sum of first 12 terms, where this is my first term, A is my 5000, my common ratio R is 110 by 100, or for the sake of simplicity I will say 1.1. Okay, so if I am trying to find out sum of 12 terms, it is nothing but A into 1 minus R to the power n divided by 1 minus R. Here A is 5000 and then 1 minus R. R is 1.1 to the power n, that is 12, divided by 1 minus R. R is 1.1 again. So eventually this became 5000 into 1 minus 1.1 to the power 12 divided by 1 minus 1.1, which is minus 0.1. So once you do this calculation, this is in bracket, and then divide that by minus 0.1, that will be the factor that will be multiplying it with. Now 1.1 to the power 12. How much is the value you guys got? 1.1 to the power 12.
I got 3.13.
So this one you got. I'm just relying on your calculator. You are saying 1 minus 1.1 to the power 12 got you 3.13, is it? Is that correct, Ansika? See? No. So okay, let's not worry about it. If calculator is the way to go, let's find it out. Yep. Yes. So same thing. So we are doing with calculator. Okay, so let's not worry about it. So 3.13 or 1.14, whatever it is, divided by minus 0.1. So 5000, this becomes minus 2.14 divided by minus 0.1. So these two minus signs will take care of each other, and then when you divide this by 2.14 by 0.1, you are actually getting almost 21.4. So 5000 into 21.4. Sorry, 21.4. So 5000 into 21.4 should give me a much bigger value, isn't it? How come we are getting 10,000 as payout? We are supposed to get hundreds of thousands.
I did it again. I got 106,121.
So here's the catch. See, 2.14 divided by 0.1. This is multiplied by 10. So 5,000 to 21. It will be little more than 100,000. And this is actually a trap. You will come across this kind of trap, okay? Where one decimal place value overlooked will give you a different answer, and even if you did all the calculation right, one small oversight will make your answer go wrong. Nobody gave me anything more than 10,000. Maximum I got was 15,000, which is still 1/6 of the value it was supposed to be. Are you guys with me or not really? Yes, Devans.
I don't know what you're talking to the school. I thought it was calculated for your value.
No, not for the 12th year value. I mean, 12th year value is a different discussion altogether. I'll come to that. 12th year value also is not going to be 10,000, I believe. 5,000 into R, 1.1 to the power 11. 1.1 to the power 11 will be how much? Okay, maybe somewhere around approximately 3. Yeah, then it will give you 15,000, approximately 15,000. But the question clearly says, okay, just read this. I mean, hear this part one more time from me. And again, I'm not trying to prove anything right or wrong with it, okay? I'm just saying that the question is our best source of information. Now, read this. If the last sentence I'm reading, okay? If the trust makes payouts for 12 years, what is the total amount paid out? The first year itself says the family trust starts with $5,000 in its first payout year. Every year increments by 10% or 110%. And if the trust makes payouts for 12 years, what is the total amount paid out? Meaning, it is certainly asking us to add up all the payouts for the period of 12 years. Yes or no? Gitesh, Ram, Ansika, Ananya, Tanu. Am I reasonably sounding okay, or I'm just forcing you guys to believe what I believe? Okay, making sense, everybody? Disali, Shikhar. Yeah. And again, see, even if I made everybody go wrong with the answer, everybody's answer is wrong, right? And nobody gave me the right answer. But does it actually hurt? No, it does not. It just makes us a little more cautious, okay? When we are solving the problem in the actual exam. Yeah? Ram, do you agree? Okay, let's go to the next problem then. A humor starts with 3 people telling 3 new people on day 1. So this is interesting, okay? We all do this. We all are partner in crime for this kind of things, okay? And we never notice that. This question is more about relating to that part of the story. It says, a humor starts with 3 people telling 3 new people on day 1. Each of those people tell 3 new people the next day, and so on. Assuming no one hears the humor twice, how many people, in bracket, total including the original 3, have heard the humor after 8 days? This is the power of humors, okay? That's what we're talking about right now. I'm reading the question one more time. A humor starts with 3 people telling 3 new people on day 1. Each of those people tell 3 new people the next day, and so on. Assuming no one hears the humor twice, how many people total, including the original 3, have heard the humor after 8 days? Everybody heard the question and the humor both? Sure. A humor starts with 3 people telling 3 new people on day 1. Each of these people tell 3 new people the next day, and so on. assuming no one hears the rumor twice, how many people in bracket total, including the original 3 people, have heard the rumor after 8 days? Thankfully, we don't know what the rumor is, but yeah, I hope you guys heard the question, so go for it. If it, yes, Devans.
So on the first page, in each one of the 3 people, 5 other first 5 people, it will have 3 people calculus.
So I will just go by what the statement says, okay? And we all will make the interpretation out of it. A rumor starts with 3 people telling 3 new people on day 1. Okay? Each of those people tell 3 new people on next day. So that is how it is cascading. So Ananya, Thanu, Disali, Srikhar, everybody heard the question, right? Yes, Devans.
So on the second day, do you have the first 3 people also have, or you only have the second 3 people have? Like only the first people have? Like the first people?
So think of this like a chain reaction, okay? I mean, you probably would not want to go back to original people, okay? So it's like you heard the rumor. Let's think of this as you, me, and Ram spreading the rumor, okay? 3 of us were there on day 1, okay? And we started spreading the rumor. So each one of us told this to 3 different people. And once we told this to 3 different people, we took a back seat, saying now these people will do our job. Yeah?
Yeah.
So you would not want to go back to the original people doing it every day and every subsequently, right? I mean, think of it, right? I mean, if you and I keep spreading the rumor to 3 people every day, we will become notorious for spreading the rumor. We just seeded that in somebody and say, okay, take it forward. I did not say anything, kind of. What is going on? Everybody working on it? Working on it hard? We just have to find out how many people have got the rumor and what is the total spread. That's the whole thing. After 8 days. And you all will be surprised to see how fast it spreads. What happens, Shikhar? You are very quiet today. Okay. No, I'm just poking you guys to participate. That's it. So Vasundhara, yeah, go ahead, Shikhar.
I think my parent asked me for 40.
140. Okay, let's see.
9,840.
9,840. That sounds more reasonable to me because rumors spread much faster than we imagine. So let me write down the numbers. How about Vasundhara? What did you get? 9,480? 9,840? Okay, Ansika. Okay. Now, how about Ram, Thanu, Vasundhara already told me. Ram, Thanu, and Disali, Gitesh, Divans.
I did the same thing.
You all got the same thing. Okay. How about Ananya? Yes. You got the same thing. Can somebody explain me how did you guys get 9,840? Yes, Divans. What did you get?
I'm confused about that question.
That's why I'm seeking help from some of your friends who will explain. Let's see. Gitesh, what did you get? 49,000. He is actually making the rumor spread faster. Okay, let's see. All right. So why don't Shikhar, you go ahead and explain how did you get 9,840? What did you do? Or you can dictate. I will keep writing on your behalf.
Alright, so first you can just you just put in your values in the equation, so it's just 3 to the power of like 8, right? Minus 1 and 3 to the power of 8 is just 6,561. So 1 minus 6,561 is negative 5,560 divided by negative 2, which will give you second. 2. So that'll just give you 3,280, and then you just multiply that by 3.
Okay. Let's see here Gitesh's version also. He got a huge number. So tell me, how did you arrive at that number so that we can.
The formula
Uh-huh.
a times r to the power n in parentheses r to the power n minus 1 divided by r minus 1, right? If you plug in 3 times 3 to the power 9 minus 1 parentheses divided by 3 minus 1, you get 3 times 19,683 minus 1, like 3 to the power 9 is 19,683, and then you subtract 1, and then multiply it by 3, which is 59,046, and then divide that by 2, which is 29,500.
Okay. Now, if I am trying to solve this one as a student, what is that I am finding here? I see that this. Okay, let me go to the question instead of me blabbering here. Okay. So this one says a rumor starts with 3 people telling 3 new people on day 1. I have 3 people. The rumor starts with 3 people telling 3 new people on day 1. So this is day 1. 3 people are telling to 3 more people. So on day 1, there are only 6 people, 3 plus 3. 3 people who started the rumor and they told to 3 different people. So 6 people is what we have on day 1. Is that a good starting point, or you guys calculate something different? See, I'm just giving the first sentence. A rumor starts with 3 people telling 3 new people on day 1. So there were 3 people who told this to 3 more people. Total 6 people is what we have on day 1. Now, each of these people tell 3 new people next day. So next day, what happened was we had these 6 people telling it to 3 people. The following day, this became my overall count, 18 people, and they were telling to 3 more people. Then the following day, it kept on getting multiplied by 3 because every day It is like whatever is your current count, you are multiplying by 3. So Devans, I am just making a small modification to the statement I made. The same people, right? Next day when you go, if you and I are spreading the rumors, next day we are a fresh person and we are doing the same thing like everybody else. We are part of the mob. We are just telling to 3 different people, that's it. So this becomes my geometric sequence where my A is 6 and my R is 3. We are talking about 8 days. So we are going from 6 to 6 into 3, the second day, third day, fourth day. My 8th day will be 6 into 3 to the power 7. Now 3 to the power 7 is how much? Let me ask this to calculator. 3 to the power 7 is how much? 3 to the power 7. Is 2187. 2187 is 3 to the power 7. So it's going. Why am I doing this unnecessarily? This is a waste of time. Okay. So it starts from here, goes all the way till this number. And we are trying to just add it. N terms that we are adding, A into 1 minus R to the power N divided by 1 minus R. Now what is my A? A is 6. What is my R? R is 3 to the power N, which will be 8, divided by 1 minus R, which is 3. So this became 6 into 3 to the power 8. Let's see, 3 to the power 8 is how much? This is 6561. 1 minus 6561 divided by minus 2. So this becomes 6 into 6560 divided by 2. Minus gets cancelled out. So this is times 3. 6560 times 3, around 19,000 something. Now it's not about my answer being different from your answer. I'm just trying to repeat and reiterate that we are clear about how are we approaching this problem. So let me read this question for you guys and then we'll try relating it with what I did, and if I made a mistake you guys can point it out. If you guys understood it differently, at least there is an opportunity for correction. You must start with 3 people, telling 3 new people on day 1. 3 people telling 3 new people on day 1. It doesn't say that every person says to 3 people, okay? So I'm not considering 3 people and then everybody saying to 3 different people, so 12 people. It says 3 people telling 3 new people on day 1. This is how it is. So on day 1, this is total number of people. Each of these people tell 3 new people on next day. So now, this was my count on day 1. Next day, each of these people, now saying each. See, the first statement did not have a word each. Second statement had the word each. So that means everybody is spreading to 3 people. And that saga continues for 8 days. Yes, it is.
So what's the difference between one person saying to 3 people? Is there like 2 answers?
I'm sorry?
So like you said in the first part, it says, it doesn't say each, and only one person, like it's 3 to 3, and not one person says it.
So, see again, you guys don't have to rely on my English, right? My English is horrible. I might be a decent guy when it comes to math. So, your only source of information would be what is there in the question. Now, let's read these 2 sentences carefully. See, you guys know how to apply the formula. There is nothing new to be taught. Right now, our focus is on how are we decoding the problem to be able to solve it. Now here the statements, okay, and you will see the difference that I'm talking about. First sentence is, a rumor starts with 3 people telling 3 new people on day 1. Rumor starts with 3 people telling 3 new people on day 1. There is no each. Okay? So with my minimum English, this is what my interpretation is. Now the second statement. Each of those people tell 3 new people the next day, and so on. So if I read that sentence one more time, a rumor starts with 3 people telling 3 new people on day 1. Each of these people tell 3 new people the next day, and so on. And if you guys find a serious problem with my English, please let me know. I certainly have an opportunity to learn something. No, I would say we just trying to relate to it, okay? I mean, nothing funny about it, though I make those dark jokes in between, but am I making sense to everybody? I mean, are you guys able to relate to it? Thanu, Vasundhara, Visali, do you guys think I'm making sense, or I'm kind of just forcing you guys to get convinced? It's okay?
No, it makes sense.
Makes sense? Okay. So see, that is where this whole strategy of this one is, okay? This RAND strategy that I keep bragging about, this has a lot of merit into it. You will see that same problem might look very easy or different when you read it a couple of times. And when you're reading it a couple of times, you'll certainly be able to be more, you'll probably get more confident about what you're thinking or what you're interpreting. So never shy away from the need of reading the question a couple of times. You guys would have noticed that in any of my class, whenever you guys ask me to read the question, same problem, I don't even hesitate to read 5 times for you guys. Many times I have read the same question 10 times also. Because I know that is your only source of information. Without reading it a couple of times, you might not be 100% correct with your interpretation. Okay. See, Ram is already feeling sleepy because of my preaching. Yeah? Okay. Alright, let's go to the next problem. This is a little different problem. A radioactive isotope sample has a mass of 500 grams. This is a radioactive isotope. And I'm not going to explain what is isotope. It is a little bit of chemistry problem, but I would assume that you are already aware of it. If it's not, you know. A radioactive isotope sample has a mass of 500 grams. So radioactive isotope has a mass of 500 grams. Every year, the sample loses 18% of its mass. Every year, the sample loses 18% of its mass. Write an expression for total mass lost over the first 10 years and find its value. So this is a much simpler problem, I would say. It is asking you, whatever information you have, convert that into an expression or relate that with your geometric series formula and then derive the value. So I'll read one more time. A radioactive isotope sample has a mass of 500 grams. Every year the sample loses 18% of its mass. Write an expression for the total mass lost over first 10 years and then find its value. So 500 grams is the initial mass. Every year it loses 18% of the mass, and then this is happening for 10 years. Write that expression first and then derive the value. And you will do all that if and only if you are convinced that this is a geometric series problem, arithmetic series problem, or harmonic series problem. And I have not taught harmonic series, but there is a series called harmonic series that exists. So I'll let you guys struggle with this for next 2-3 minutes, and then I will check. Everybody is clear about the question, right? Gitesh, Divans, Shikhar, Nanya, Tanu, Niska, Ansika. I have to get better with pronunciation of names. Sorry about that. Disali, Usman, everybody.
Sir, can you repeat the question again?
Okay. This says a radioactive isotope has a sample. A radioactive isotope sample has a mass of 500 grams. Every year, the sample loses 18% of its mass. Write an expression for total mass lost over first 10 years and find its value. Yeah?
Okay, thank you.
Yes, Ansika.
Can you repeat like the last line of the question? Just the last line.
Last line says, write an expression for the total mass lost over the first 10 years and find its value. Mhm. And I'm here only, okay? If you are thinking that teacher disappeared, that is not the case. I'm right in front of you guys looking at who is doing what. So Riyahi, Ananya, Deval, Tisali, Tanu, Sudra, everybody give it a try, right?
Are you asking what the mass is at the end?
How much is the loss? How much is lost? That's what the question says, okay?
Okay, so what the expression would be 500 minus parentheses 500 parentheses 1 minus parentheses negative 18 over 100 parentheses and then to the power of 10 close parentheses and then divide by 1 minus negative 18 over 100 and then close the entire thing.
Okay. I'm not sure if I've written it correctly.
Yeah, that probably didn't get it.
Yeah, that's it.
One second here.
Come on. This guy is, see.
Yeah, that's basically right, but the 500 is on the side and the main expression has parentheses on it. But
Okay.
yeah, that looks right.
So, yeah. So anyways, I will rewrite it and then,
Yeah.
we'll verify it.
Yeah.
And by any chance, did you get the value?
Yeah, I did. So the value for the loss was 76.27.
76.27. That many
Right.
grams.
Yeah.
So the radioactive substance, which was 400 grams in mass, became around 400 something, 426 or something.
Yeah, 423.72.
Okay.
Well, 73.72.
Okay. We'll see. So we have just 3 more minutes. So I will probably, I'm sure you guys are already doing it. I will just convert this expression, then we'll try doing some approximation to make sure that we are all in the right direction. So look at this. This says 500 grams was the initial mass. Every year it reduces by 18%, and this is happening for 10 years. So first year initially it was 500 grams, and after 1 year it became 500 into 1 minus 18 by 100. This was the reduction that happened. So 500 became 500 into 1 minus 18 by 100, and that was the new mass. And this is exactly the reduction that is happening every year. So the subsequent year it became 500 into 1 minus 18 by 100. This whole thing is squared. So 1 minus 18 by 100, this is getting multiplied every year. Correct? Secret? 1 minus 18 by 100 is getting multiplied every year. That's the reduction that's happening. Correct? Yeah. So this is by R. And 1 minus 18 by 100 is nothing but 82 by 100, or okay, yeah, 41 by 50 kind of a thing. Okay, 82 by 100 or 8.82 basically. 0.82. Let's not complicate it. So my A is 500, my R is 0.82, because that's what I'm multiplying by every year. And how many years? Initially 500. So this is 0th year. First year is this one. Second year is this one. So we talk about 10 years. So we will go all the way till 500 into 1 minus 18 by 100 to the 10th power. So essentially we are talking about adding 11 terms. Yeah? Shikhar, did you count 10 terms? 10 years or 11 years?
Yeah, it's 10.
So we have to count for 11 terms in the sequence, because this is a starting one. A is your 500 when this is 0th year. In the first year you have 500 into 1 minus 18. Second year 500 minus times 1 minus 18 by 100 to the power 2. So you are going for 10 years. So you are looking at total 11 terms. This is the first term, this is your 11th term. Yeah?
Yeah.
So sum of 11 terms would be A, which is 500, into 1 minus R. R is 1 minus R is 0.82 to the power 11 divided by 1 minus 0.82. So what I am emphasizing here is we have to be also right with our count. The obvious temptation is I am talking about adding first 10 terms. No, we are talking about adding first 11 terms. Because your first term, once you look at this data and convert that into the geometric series or geometric sequence, you are looking at, this is your weight for the before the things start. After this thing started, 500 into 0.82. After first year, this is the data. We are talking about 11 years. So we are talking about 500 times 0.82 to the power 10. This is first year, second year will be square of this, third year will be cube of this, 10th year will be power 10 of this. So essentially you are looking at a geometric sequence. This is the first term, second term, third term. This is your 11th term, not 10th term. So when you are adding it up, you will talk about sum of 11 terms. Wherever you have n, you will put 11 against that. One minus 0.82, this is your common ratio to the power 11 divided by 1 minus 0.82. This is what I am trying to reiterate. Did you guys think about 11 terms or 10 terms? Not look at this. Seeker, question to you, Vita. So did you consider 10 terms to be added or 11 terms to be added?
Yeah, I put 10.
10.
Yeah.
So, but we have to count 11, right? I mean,
Yeah.
yeah. So sum of this thing sum of, okay, what am I counting here by the way? No, I'm unnecessarily going the wrong direction here. It's talking about what is the total loss. Meaning after 10 years, what is my new mass, and subtract this mass from 500. That's what we have to do. Yeah. So basically it is going to be, this was my original mass. After 10 years my mass became, not my mass of the radioactive substance, 500 into R, which is 0.82 to the power 10. So this was my original mass, this is my new mass, difference of that will be my loss. Yeah. So here 10, power 10 is fine. I mean, you are finding the 11th term, which is to the power 10. We are not summing it up. Okay. Am I getting you guys confused? I think so. No? So let me acknowledge what I was doing. Initially I was adding up all the mass, but that is not what the question says. Question says, what is the total mass that we are losing over a period of 10 years? Meaning, what is the mass at the start and what is the mass at the end of 10 years? So this is the 10th year. This is the mass, because you started with 500, next year became 500 into 0.82, next year it became 500 into 0.82 square, and it continues. So after 10 years, what is the mass that you got to? And original mass minus this mass will be your mass lost. Correct? So we have to subtract. It's like subtracting from A the nth term. Yeah? Yes or no? Okay. So I'll leave you guys here, and what I will do is I'll send you all few more examples or sample problems that I would want you guys to do as an assignment, just to make sure that we are not only learning the formula, but when it comes to applying it. See, do you guys need to be this intelligent for applying the value in this formula? No. And for Algebra 2 batch, it is not going to be a pure play application of formula. Okay, this is your A, this is your R, this is your N, plug it in. It's not going to be that easy. It is certainly going to twist the question a little bit by putting some story around it. And how do we decode the story will ensure how right or wrong we go with respect to solving the problems. Okay. Yeah? Alright, so with that being said, I'll let you guys go. And we'll meet again in next class. Alright? Alright. Yeah. Yeah. Bye bye.